Hello everyone, welcome to my channel. So today we are going to do tries whatever questions which are there from starting till end. Means basically what we are going to do is we will start with the basic, means the basic implementation of the try, and then we will just level up one by one with some of the modification. And this playlist which I am making, this you need to follow the way I am uploading these videos, like that only you need to follow. Then only you will be able to get whatever intuition is required for a particular try question. Although for tries, in the first question itself I let you know that when we are required to use try, means all the basics which are there. But coding that particular, for that purpose you need to watch this playlist and solve all the questions which are present in this playlist step by step, rather than jumping over the last question. So I hope this playlist would be completely useful to you all, and if you really like this playlist, do share this among your friends as well. So without any further ado, let's start. So I'll be sharing my screen. So here's today's first question: implement try prefix tree. So basically, as per the name, what a try is about, here for try them itself they have mentioned about the prefix tree. Basically, how the try actually is, let's first understand that. So see, there is one parent node which is there, and from that there would be about 26 nodes, and these 26 nodes are of alphabets, that is A, B, C up till Z. So basically from A to Z all the characters would be there, and then further this A would be having further 26 nodes, and like that there would be ongoing nodes like that. So this is the basic structure of a try which is there. And when we exactly use this, means this is the basic structure, and when to use it. Now if we are required to solve question where prefix is required, prefix for that particular, means whatever words which are given to us, we need to search into the same, do check for the prefix or check for the even suffix, because in suffix anyhow we can reverse and use that type of question also we'll do in this particular playlist, I'll show you. But the first thing is that try is mostly used for the prefix things, means whatever word which is given to us and that prefix we want to find. So see, in this also, this particular example which is there here, apple, we have inserted the apple, then we are searching for the apple. If in our try we have already one node, means already we have one node like this, right, and we are able to search this particular, right, so we will be returning true at that particular moment. So like this, when we search for app, then we will be returning false, because here this app is just a prefix of that particular word if a whole word is required to be searched. But if we are required to search for the prefix, then we would have been returning true here. Like here it says starts with, means we are required to search here a prefix, and for that this app is there, so that's why we will be returning true here. So like this was one of the basic example that where this try is being used whenever we are required to do searching in a particular prefix tree, which we usually call as try. So for that purpose we can easily use try. And now the next thing which is there is that how we are required to solve this question and whatever try questions which are there. This is the first level question which we will be solving, and make sure you follow step by step rather than rushing ahead with whatever complex questions are there, else you won't be able to get the intuition. So now let us get started. Now let us read this question. Now this was the basic. I hope you are clear with the same. If you're still not clear, you can comment that down. I'll solve the queries. So let us just read this question first. So now here the question which is there. So a try pronounced as try or a prefix tree is a data structure used to efficiently store and retrieve keys in a data set of string. There are various applications of this data structure such as autocomplete and spell checker. Yeah, whatever we have in our Google search, the autocomplete which is there, or even the spell checker, and that try is also used. Not also, but try is one of the main thing which is being used. Now the question which is being given to us in this, what we are required to do is, so basically here we are required to implement the try class. Now basically we will be going to implement the try class, means the thing which is being used even in the Google search. So now here try initializes the try object, inserts the string word into the try, and boolean search, where input is string word, returns true if the string word is in the try, that is was inserted before, else it will return false. And starts with, and string prefix would be passed for the same, and for this particular it will return true if there is a previously inserted string word that has prefix and false otherwise. So these are the things which would be there, and now these are the functions which would be there. This is the class which is there, which we need to implement. Now the next thing which is there, the input. Although earlier only I have explained this input, see, if we are given with, like first thing, this try initialization which would be there, then we will be inserting this word. There is one note, and then at the A, then we insert this apple, and as this is a word, then at the end we will just mark as true, that yeah, this word was being inserted. That would be the thing. And here the next, when we search, so we will be able to find and will return true. Then we'll search with the other word, then it will return false. If we search for a prefix, that yeah, there is a prefix, it will return true. Then we'll insert this app, then this app would be inserted basically, here it is already there, right? So just at this particular point it will return true, means it will have that here also one node would be inserted for the true. Now if it search for the app, then it will return true. So that would be the thing. Now this was one of the example. If any other example, like we say boy is there, we inserted a word boy, and here it will be having true with its node, and if we search for this word, it will return true. But if it search for the word boycott and it is not here, then in that particular sense it will return false, and that will return false just beforehand only, when it will not be able to figure out that C was there. But if we insert C, O, then T, and then T, and then there was true also for this particular node, then it will return true. That is the thing. Means basically here I have discussed three scenarios. First scenario, the whole word which is present. Then the second scenario which is there is, if prefix which is there, if it was searched as a prefix, then it will return true. But if it was not searched as a prefix but as a whole word, then it will return false as per this question. And the third scenario which is there is, if a smaller word is there and we are searching for some bigger word, right? Then in that context it will return false, because it won't be able to figure out this particular portion, and that's why at that moment only it will return false. So these are few of the cases for this particular question, and I hope till now you are clear with the question explanation part. If you have any doubt, that also you can just comment. And yeah, you can even take a screenshot and then start with the coding, because these cases are required to be checked. Now the next thing is about the coding part, how we need to code it. So in this first video, just learn about how we are required to implement the try. Then upcoming videos you will be easily able to code by yourself. So now let us start with the coding part. Now here the trie which is there, basically here we are required to take some other data structure for the storage purpose, and that will create a trie node. And how we are required to go ahead for the same is, so here the thing is that what type of things we are storing. Here we are storing just a string which is there, right? We are required to store a string, and also we are required to have that if that ends at that particular point or not. Only two requirements are there. So according to that, that will specify a data structure here. So as we are storing string, and we are not required to even do some sort of lookup the way we used to do in unordered map or unordered set or map, right? We can directly just use this trie data structure, traverse one by one over those nodes, and we can get a final string. So for that purpose only, we will be using a vector, and the data type of this particular vector would be trie star, basically the pointer towards the node which would be there, and we will name it as child, because anyhow this will act as a child node for each and every character which is there. So that's why. Now the next thing which comes into picture is about the bool, means ends with or something like that. So in that context only we are required to code now. Now for that purpose, bool ends with, this will help us to know that if that particular is the last character of the word being inserted or not. So that's why we will be taking this particular variable. So that's the thing. Now these are the private variables of this particular class, and in a class these variables anyhow this is the same class only, right? So that's why it's fine for this. But if we were using this class with some other class, then yeah, for acting these variables as the object, means utilizing these particular, we would be requiring setter and getters, right? But the best practice for everything is that we should initialize it with some default value like 0 or null, something like that. So for that purpose, what we will be doing here is this particular default constructor which is there. So we will be initializing our variables in this particular default constructor only. So for that purpose, I would be using initializer list. So now here, this child which is there, we all know that it will be storing 26 characters and it has a pointer. So that's why that pointer is required to be initialized with null. And the ends with which is there, at the starting, we will be initializing it with false. So that is what we will be doing here. So initialization part is done for this trie node. Now comes the part implementation for this particular question. We need to insert, we need to search, and we need to check for if it starts with it or not. Now insertion in a trie. So we are using this particular data structure, means vector, which has the type trie star, means the type of the class itself pointer to that particular class. So we will be inserting in that. But how we need to insert? So every class has an object, right? And utilizing that particular object only, we will be doing any operation over that data structure. So for that purpose, now for this particular pointer, means for this particular only, for this class we will be creating a pointer object so that we can basically utilize whatever variables, members, objects, whatever are there, we can utilize them. So for that purpose, we will be creating a pointer object trie star, and we'll just initialize with this, so that whatever things are there for this particular class, that we can use. So that's the thing. Now the word which is there, we have a single word which need to be inserted, but each word has the characters, right? So those characters are required to be inserted. So we will take the character from that particular word which is there, and then After taking that particular character, what we will do is first we will check our try node which is there, our current object which is there. In that it will check if the child which is there, it has this character or not. This index value would be from here, int index equals to c minus a. This will give us the index of that particular character, and we all know that basically all the characters are being stored in the trie from a to z, right? So whatever character which is there, if we subtract a from that, it will become 0, means index would be 0. So at index 0, if this particular c character which is there, it is a, then it will be pointing towards a. So that's why. So if that particular character doesn't exist, then in that context we need to create a new node. So for that purpose, what we'll do is we will be having this current child of index, right? And to this we will assign a new try. Basically a new node gets created after this. So that is what we are trying to do in this. Minute. So that is what we are trying to do here. Now the next thing which is there, if it already exists, then in that context we need to just move ahead for this particular this is what we will be doing. We will be just moving ahead, and after this, because here the thing is that we are required to check if that particular word got inserted or not. So that's why at the end, after this particular whole word got inserted, we need to mark current ends with equals to true, so that the last character which is there, it will be having the value true, and that will let us know that this complete word got inserted. So this was the part for the insertion. Now the next thing which comes into picture is that how we are required to search for this particular word which is there. So for searching this word, now the word, almost the code would be same, only what we were doing there, a little bit modification, but things would be same. Again we would be required the pointer object of this particular class, initializing it with this, and then we'll again start with char c in the word, and then we will be checking that first we will be having this index, and then we will be checking if that particular exists or not. That is the thing which we will be checking. If this particular doesn't exist, here the thing will change somehow. If it doesn't exist, then we will be returning false here. That means this particular would be that scenario where we were searching boycott in boy word, right? And boycott was not inserted, right? That C was not figured out. So this would be that note that C is not there, and it will return false. So this is that scenario. But by chance, if it existed, means it existed, then in that case we need to move forward, and for that purpose we will be just moving forward the way usually we do. So like this it will be able to search the whole word moving forward and so on, and when word gets exhausted, then it need to return basically current ends with. So if that ends with is false, because there could be a scenario like it was searching for app, right? In apple means the whole word it was searching, right? But app was not inserted at the start, but in that scenario apple was the word which was inserted, and at e only it will return true. So in that scenario it will return false, where already nodes further are existing, but that node is actually not the one which is required by that particular word which we are searching. Means I hope it is clear. Actually means I'm saying about this particular fact. means here. So we are searching for app, but other nodes are already existing, but we are searching for this app only. This is a search, but here this node would be having false. So when we are doing this, in this scenario it will return false, but if we are searching for apple, it will return true because this particular would be having true. And when it returns false, when there is a word like boy, right, but we are searching for boycott. So here C won't be there, and that's why here only it will return false. So these are the 3 examples which we have discussed at the start, right? So that we have covered here. Now comes the next part, and that next part is about searching for a prefix. So here again prefix would be also somehow similar to the search, only a little bit modification is there. So now again we will go ahead, try star current equals to this, means creating an object of the class, and then we need to check for char C in our prefix, and then we need to check, means just for simplification we are taking this index, and then we'll check if not exist child of index. If it doesn't exist, right, then in that context we will be returning false, and we will be moving ahead and doing current child of index, and then at the end we'll return true, because if that existed, right, if that existed then it's fine, that it existed. That's why we are returning true rather than returning ends with, because see, app which was there, if we were searching for just for the prefix part in the apple, then we were able to figure out that whatever a p p word characters which were there, we were able to figure out, right? So that's why at the end we will return true. So that's the thing. That was just a simple modification to the same. And now comes the part for the time complexity and the space complexity. So for inserting all of this, we can see that the words which we are inserting, the length of the word, basically anyhow at the start, in this example we have inserted just one word, but there could be several words, and at max the length of the word, again it can go up to 2000 and so on. Okay, fine. So anyhow, this search which is there, that is dependent upon the length of that particular word. Here also the insertion, that is dependent upon the length of that particular word, and this starts with again dependent on the length of that particular word. So all of these operations which are there, that are completely dependent upon the length of that particular word. That is like if we take the word order length of the word as L, then this operation takes order of L time, because anyhow each time we are just inserting a single word, and that's why. And this particular operation takes again order of L time, and this particular operation takes order of P time, where P is the length of the word which is there. So basically the time complexity here is linear as per the length of their words being inserted or searched. But if it would have been something else, then it might have gone much more higher than the way we are getting here. So this was all for this particular video. If you really find it useful, you can share this among your friends also, and yeah, if you have any question in your mind, that also you can comment. So yeah, this was the first level video of this particular topic. We'll go ahead with the next level video in the next video, so stay tuned for the same. Thank you.